In this video, we're going to be solving systems of two equations. Now, there's different methods to doing this as you learn in algebra and algebra trig. But we're going to be using them again, and we're going to be solving nonlinear systems along with linear systems. Now, first we're going to work with the substitution method. Here's an example of a system of two linear equations in the two variables x and y. 2x minus y equals 10, 3x plus 2y equals 1. Now, a solution of a system of two equations in two variables is an ordered pair of real numbers that's a solution of each equation. For example, the ordered pair of 3, -4 is a solution to the above system. We can verify it by putting in 3 and -4 for x and y. You'll see that they get 10 when you put in the 2x minus y equals 10 and 3x plus 2y equals 1. So it's going to tell you that both equations are going to be satisfied. Now, we solved the system of equations when we found all of its solutions. In example 1, we're going to use the method of substitution to see that 3, -4 is the only solution of this system. And that will be for example 1a. So we're going to solve this by using the substitution method. Now, generally when you use this, you want to use the equation that's easiest to solve for one of the two variables, either x or y. So we're going to choose the first one here. We're going to solve it for y. So I'm going to add y to the other side, subtract 10 over here. So really, 2x minus 10 will equal y. Plugging that in for y, 3x plus 2 times 2x minus 10 equals 1. Now, what we've done, we've put the equation into the other to get only one variable. So like 3x plus 4x minus 20 is equal to 1. Solving this, we get 7x is equal to 21. Dividing by 7, you get x is equal to 3. So what we're going to do then, we're going to put our value x into x up here. 2 times 3 minus 10 will equal y, which means 6 minus 10 is equal to y, which means -4 is equal to y. Our solution then will be 3, -4. Now in example B, we can do this a couple different ways. I'm going to choose the bottom equation because x is positive here. So x will equal 2y plus 10. Plug that in for the top equation. We get that answer there. Simplifying by distributing, we'll get 6y plus 30 plus y equals 20. Combining and subtracting, we'll get 7y is equal to -10, which means y will equal -10 over 7. Plugging that value into our value up at the top, x will equal 2 times -10 over 7 plus 10. 2 times -10 over 7 is really -20 over 7. 10 can turn into 70 over 7. So simplifying this further, you get positive 50 over 7 for x. So your answer, 50 over 7, -10 over 7. In this video, we're going to talk about the method of substitution with nonlinear equations. So if we take a look at example 2a, we have 2x plus 2y equals 100 and xy equals 300. Well, we can change the top equation to x plus y equals 50 by dividing by 2, which means x will equal 50 minus y. Using that fact, we can change the x in the bottom equation to 50 minus y times y. That will equal 300. By distributing the y, we'll have 50y minus y squared is equal to 300. Putting everything on one side, by putting the negative y squared and the 50y on one side, we'll get y squared minus 50y plus 300 equals 0. Now you should be able to see that there are no two factors of 300 that give you 50. So what we're going to have to do here is actually complete the square. So bring the 300 to the other side, make it negative. Half of 50 is 25. 25 squared is 625. Simplifying this in factoring, we'll end up with y minus 25 squared equals 325. When you solve this for y, you'll end up getting y is equal to 25 plus or minus the square root of 325. Now, obviously you can see there's going to be two answers. 25 plus the square root of 325. 25 minus the square root of 325. So the positive one will be 43.03. And then y will also equal about 6.97. Now to find x, since x is equal to 50 minus y, 50 minus 43.03 is 6.97. 50 minus 6.97 is 43.03. So when y is 43.03, x will be 6.97. When y is 6.97, x will be about 43.03. So your two answers, we'll take the first one here, will be 6.97 and 43.03. And our second answer will be 43.03 and 6.97. So those are your two answers to this solution. Now if we graph them, you should see 2x plus 2y equals 100. Again, make sure you're in function mode. Does not matter between radian degrees, just keep it in degree. So we'll have 2x plus 2y equals 100. Okay, we have to solve this then, so it'll be y is equal to 50 minus x once you solve it. And then xy is equal to 300, so our second equation will be 300 divided by x. I'm going to go zoom. If we go standard, it's not going to work. So if we go zoom fit, you see that it will work here. Actually, we're going to check our window here. Let's see what it looks like. Wow, y min, y max is crazy big. So let's change this to say negative 200 to 200 to see what we get. And we'll change our x min, x max. We'll go negative 50 to 50. As you can see, our first intersection will be here when x is about 6.97 and y is 43.03. Our second intersection will be down further here when x is 43.03, y will be about 6.97. Therefore, your answer is correct. Now, for example B, if we solve the second equation for y, y will equal 9. That means 9 will equal x squared. That means x will equal plus or minus 3, because the square of 9 is 3. So our answers will be 3, 9, or negative 3, 9. That's a nice easy one to solve there. But again, it is nonlinear, so that's why it works.